Welcome to Freedom Laboratories.
Hi, I'm Dr. Tran, Senior Engineer. Here at Freedom Laboratory, we specialize in brain-computer interface devices.
Today our team will be introducing our latest device, the Freedom Bed.
Let's take a closer look.
Today we'll be covering the design, purpose, advantages, limitations, block diagram, EEG signal processing and acquisition, as well as the feasibility and safety of the Freedom Bed.
This mechanical model is the skeleton of the Freedom Bed. As you can see, the headpiece and the leg piece can rotate with 30 degrees of freedom side to side. They can also be elevated and declined by 90 degrees, which can transform it into a chair. The base can be rotated 360 degrees, allowing the user to see completely around the room. The sides are curved to hold the patient in the middle of the bed. Features not shown would be the medical-grade mattresses, side rails for additional safety, and the computer interface itself to allow the user to interact with the device. The following is what the device would look like with the mattress and the safety rails included. The purpose of the device is to improve the quality of life for quadriplegics by giving them more degrees of freedom and independence. Also, it will prevent injuries such as bed sores with its flexibility.
Our device has many advantages that improve user independence and positioning. The 30-degree rotation range allows the user to alleviate pressure exerted on the body and prevent bed sores. Lastly, the Freedom Bed reclines and declines, which gives the user more position options. The limitation of our device is that many hours of training are needed to acquire accurate signals. Also, the current design consists of a stationary bed. In the future, we hope to add wheels that the user will be able to control with other EEG signals.
What makes our product unique is the special algorithms used for training, correlating signal movement, and safety measures. Our device first trains with the user to obtain signals from the person, and adapts the device to them. EEG is stored and the mean squared error is calculated, and if data is good enough, the BCI will accept the signal. Afterwards, the BCI is functional and remains at a steady state where it's in standby. Certain signals from the user, such as mu suppression and SSBP, causes different movements of the bed. If the movement exceeds safety limits, it is ignored. Otherwise, each accepted signal moves the bed in increments and returns to standby.
EEG signal acquisition will happen with an integrated amplifier. The raw EEGs will be obtained and briefly stored in and processed with the computer. The main processor will run through the algorithm shown in the block diagram. One important factor we had to look at was the electrode placement on the patient's scalp. In order to reduce discomfort and reduce the standard amount of electrodes that the 1020 system uses, a new montage was created by Freedom Laboratories. This EEG montage will have one electrode in the center of the scalp where noise is the smallest for the reference electrode. Two more electrodes will be placed around the center of the scalp by the motor cortex where the new waves are the strongest. Studies in UCSD have shown that these two electrodes should be efficient enough for our purposes. Two more electrodes will be placed on the occipital lobe on non-hair-bearing regions, which will detect SSVEPs with two more targeted movements. Finally, one electrode will be placed on the frontal lobe where ocular artifact is the strongest.
Simplicity is a large factor in the feasibility of the Freedom Bed. Only necessary features have been incorporated. The simple mechanical design, basic operating movements, and existing features of a hospital bed keep the production and operational costs low. To ensure safety, rotation and declination limits have been placed. The emergency stop function, blinking 3 times in a specified interval, results in a strong signal that allows the user to halt all movements of the Freedom Bed. Additionally, the curved design with side bolsters will keep the patient in a comfortable and safe position. Using our algorithm and electrode placement to acquire and process EEGs, we've created a device to give quadriplegics more independence and freedom while also incorporating features to ensure safety, feasibility, and comfort.